Hello, I'll be doing the demo for 310 Campus Explorer for our team, and I'll briefly go over our architectural design because this will make a lot of sense. For the front end, we decided to have this kind of architecture all going through the inside API, and we have our server with 4 very important REST endpoints. And yeah, I will be demonstrating them right away. So first off, I'm going to run the server. We can see that the server is here. I'm just going to quickly inspect the network so that I can show you the different requests. We'll be focusing on fetch right over here. Okay. And we're going to load the room dataset. This should request a few functions. And so right over here, we have we fetched our app in our app.tsx. We fetched the campus zip. Again, it's all going through our inside API. So let's go to inside API line number 4. As you can see that we added our room dataset, which is notified right over here. And then we also have fetch rooms and fetch buildings. So to fetch all the rooms in the building, we do have our REST endpoints, which are all handled in our inside API. And so that's pretty good. And first I will go through the Campus Explorer demo. The map is right over here. You can see different buildings. There's Orchard Commons, Forestry Building, and yeah, so that's the functionality. We should be able to select the alert hall. You can see the room information is available. If we do select the CAM building, so one of the CAM buildings, you can see now the walking time distance between Allen Hall and Chemistry. So that's just to show you the basic functionality that we should be able to do. Before we move on with the different things, I think it's going to be really helpful if I go over the user stories so that it's a lot clearer. So one of the user story is that as a campus visitor, we want to be able to load the dataset and see all the buildings. And as I showed in our functionalities, we're able to see the different locations and the different buildings. And they're also marked appropriately. We made a map component using Leaflet. That's the thing we used. And then of course there are different fetch APIs that are all handled right over here. And yeah, that's if we try to select, as you can see, as you'll see later, if you try to select more than 5 rooms, you'll get an error message as well. So yeah, one of the first user stories is, we fetched all the requests right over here in the add rooms dataset. We fetched the rooms and we also fetched the buildings. So user story 1 is done. Let's move on to user story 2. And as a student in GBC, I want to be able to search the rooms where my classes are handled. So we should be able to select up to a maximum of 5. And if there is more than 5, we'll get an error message. So let's start selecting right away. We have 2 over here. We're gonna go. Let's select HEB. Minimum seats, maybe like 5. Let's apply the filters. These are all the buildings with minimum seat of 5. Let's choose HEB 100. And yeah, we have updated it right over here. You can see that there's another request right over here for line number 46. So every time we're trying to fetch these rooms, we're actually filtering the room. And the request is right exactly over here. We're doing a fetch request, as you can see in the network request. All right, it's still 3. We need to get 2 more. We're going to have the LSK, apply filter. There we go. One last one to go. We're gonna do Woodward, apply, and there we go. That's 5. All right, so I'm gonna get greedy. I'm gonna add 1 more building, apply filter. So if I try to add 1 more building, it says you can only select up to 5. So there we go. Initially, when we only had 1 data, there wasn't any walking time, but now that we have 5 data, you can see all the different combinations that it takes from alert hall to chemistry. So yeah, the different meters and how long it will take in approximation, all of these are actually filtering the room. And yeah, we also have a different algorithm that actually calls it. So after we selected our room, we're gonna move to our detailed room information user story. So as a professor, sometimes when the professor picks where to lecture in, they want to see several detailed information about the classroom. And all of them, worry not, we got you covered. You can see the information right over here, the number of seats, where the address is, what the code is, and the short name font. Yep. And so, yeah, that's the thing in user story 3. All of this is called in the room request right over here. And yeah, that's user story 3. Let's move on to our final user story 4. So yeah, every time we select more than 2 rooms, there are walking times, as we can see right over here. So we design a component to render the walking times and then do a distance calculation, which I'll show you the code very soon. And so yeah, there are the different walking things is available here. So in our specs, we mentioned that we should be able to delete them as well. So if we delete it and there's only one left, then the walking time should not be there anymore, and it disappeared right over there. Perfect. So yeah, and so let's move on to the other parts of the video. So we showed all the network requests, and we did go through all the user stories, and I did show you how the network requests are handled, and how each user story is relevant to each network request. For the integration tests, let's start it up right away. So the integration tests, we actually tested the 4 main important things. One of them is to load the data set. This is for the front end. To load the data set, trigger the API, and display a success message that we did. As soon as we went into the server, it said like we loaded the data set. Of course, let me show you the user story number 1. So we're doing the mock loading screen, making sure there's a success message, making sure the map is actually rendering. This is a map container component. The different part of the another user story is to select multiple rooms with a limit. If we can only choose more than up to 5. So yeah, this is also passing. Same thing with the other things. I'm just gonna scroll through so we can see the different user stories. We are asserting room data, and of course in the final user story, the walk time is if there are 2 or more rooms selected, there should be a walk time. And we tested it with certain rooms like DMP 110, a place all computer science usually visit. So yeah, and all of them currently passed. And so to show you the front end part of the code, so in our architectural diagram, you should be able to see that all of these requests are HTTP requests. They're handled by the server.ts, and although they're designed in the inside API, as you can see the request over here, we're fetching. It's all handled inside the server.ts. So the first user story, we wanted to add the data set. So we did it right over here. And then also in the server, we had middlewares. That was the specs that was given to us by the professor. So we decided to use this express, and we registered the routes. We also had the add data set. So this request right over here, when we were adding the rooms, when we were adding the buildings, all of this is handled inside here. Yeah, this is the code. I'm not sure if we have enough time to explain it. This is also handled. The get rooms are handled here, get buildings are handled here. Whenever we select anything over here, like orchard here, we have a filter fetch request, and it's also handled. The filter room is handled right over here. Yeah, and if there are any errors, it's handled in the server side as well. So that's everything for our code. So we also showed you the front-end pack integration tests. We showed you the different server endpoints. That's pretty much it. Thank you very much for your time.